Welcome to What is Semantic Search? Powering AI Applications. I'm Kassian with NetApp Instacluster, and today we will set up semantic search on a NetApp Instacluster OpenSearch cluster. These instructions can be easily adapted to wherever you host your OpenSearch. Today, we'll cover the basics of what semantic search is, with resources to learn more in the description. Then, you'll learn step-by-step the process to leverage semantic search in your OpenSearch cluster. Finally, I'll cover why semantic search is important to nearly all AI use cases. So what is semantic search? Semantic search allows us to search by context and meaning rather than exact text and data matches like traditional search. We go from searching for exact matches to close matches, or we can even predict trends using existing data and AI tools. When you make a request to a semantic search, your search is turned into a vector embedding by the AI model, then used to search the existing data. There's a lot to go into here, and I've included some more links in the description. In the final section of this video, we'll explore how semantic search powers nearly all AI applications. Now I'll walk you through setting up your own semantic search on NetApp Instacluster OpenSearch. The steps include choosing an ML model to use, creating an OpenSearch cluster on NetApp Instacluster that runs the ML Comments plugin, register and deploy the model, register an ingest pipeline for the data, ingesting that data, and then searching that data. For this example, you'll use the Distilbert model from Hugging Face. This is a natural language processing model, good for searching text and finding similar results based on context and language meanings, otherwise known as a semantic search. Creating the OpenSearch cluster on NetApp Instacluster is very straightforward. The only thing you absolutely need to enable is the AI search plugin on the cluster. After that, you're good to go. Cluster deployment will take about 10 minutes. You can use that time to check out other videos on related topics that are linked in the description. Now that your cluster is up and running, you're going to register their model with the cluster and then deploy it. This will make the model available to your OpenSearch processes and searches by creating an ID for it. You can find a link to all of these scripts in the video description. Registering and deploying a model creates a task ID because it is an asynchronous task for the cluster. You'll use another curl call to check on the status of the model. Once the task is completed, it will produce a model ID under model_ID in the return JSON. Save this somewhere safe. You'll need it for future steps. Now that we have access to an AI model for language processing in our searches, you'll want to have data to search. In order to do that, you'll need to create an ingest pipeline that transforms input text into a vector embedding that you can use to search that text. To do that, you'll use another curl request. Let's take a look at some of the important fields in our request. The example-nlp-ingest-pipeline in the URL sets the ID for the ingest pipeline, which we'll use later. Model_ID needs to be set for the model ID you created in the last step. In the field _map section, there is a text set to passage embedding. This tells OpenSearch to translate the text in the text field of the request into a vector embedding, and then store that embedding in passage_embedding. You can now run the script to create the ingest pipeline. Now that you have an ingest pipeline, you're going to create an index to hold your searchable vectors. To do this, you're going to, you guessed it, make a curl request to the OpenSearch cluster API. This request creates an index called example-nlp-index with a text field for the original text and an embedding field to hold the embedding created by the ingest pipeline. You have the ingest pipeline, you have the index, now it's time for the data. You'll use curl request to create 10 documents made from movie descriptions. You'll need the ID of the ingest pipeline from the last step and data in the gist from the description. You're going to send these in, and the ingest pipeline will transform it into a vector embedding for you, using the Distilbert model that we chose in the first step. Once the documents are in, you have everything you need to perform a neural search. One last curl script. All you need to do is tell OpenSearch that you want a neural search and the index ID of the index created a few steps ago so that OpenSearch knows which index to search. Once the search is complete, you can view the results, which will give you matching titles not by keyword, but by context. So what can we do with semantic search? As it turns out, nearly all AI applications, such as Retrieval Augmented Generation, or RAG, conversational chatbots, agentic AI applications, and much, much more. Semantic search helps us understand the internet beyond keyword matching and understand data in context. Because it analyzes relationships between data, you get results that are actually related to your user intent and context. In this video, you built a semantic search app on OpenSearch on the NetApp Instacluster platform. You also learned more about semantic search and how it powers AI. Thanks for watching, and like and subscribe for more.